Ever wonder how a program seems to think, how it makes decisions? Well, at its core, all code is just constantly arriving at these little forks in the road, and it needs to know which path to take. Today, we're going to teach our code exactly how to make those choices. I mean, think about it for a second. When an app asks for your birthday, what's really happening behind the scenes? How does it decide to show you one screen if you're over 18 and a totally different one if you're not? This is the exact kind of problem that conditional logic was born to solve. And at the heart of all this decision-making is just a few simple keywords. We're about to see how we can give our programs the ability to react intelligently to all sorts of different situations. Okay, so this brings us to the main event, conditional statements. These are, and I'm not exaggerating, the absolute foundation of making decisions in programming. It's all about asking a question that has only two possible answers, true or false, and then acting on that answer. So where do we start? Well, we start with the most basic question you can ask, the if statement. You can think of this as the simplest possible gatekeeper for your code. The if statement is super straightforward. It's like a bouncer at a club. It checks a condition, like checking your ID, and if, and only if, that condition is true, it lets a specific piece of code run. If the condition is false, it just shrugs, skips that code, and moves right along. Let's make this real with an example. First, we create a variable, age, and we set its value to 20. Then, our if statement asks a very simple question. Is the value of age greater than or equal to 18? Since 20 is definitely greater than 18, the condition is true.
So here's the play-by-play of what Python is doing. It checks a condition, it sees that it's true, and because it's true, it executes the code that's indented right underneath it. Simple, direct, and to the point.
But hang on, what if the condition is false? Just skipping the code isn't always what we want. Sometimes we need a totally different action to happen. This is where we give our program a clear fork in the road. And this is where the if-else statement comes into play. It gives our code two distinct paths. If the condition is true, one block of code runs, but if it's false, the else block runs instead. Now our code is guaranteed to do one thing or the other. All right, let's see this one in action. This time we set age to 15. Python asks the same question. Is age greater than or equal to 18? Well, this time the answer is clearly false. So it's going to skip the if block and go looking for an else path to take. And here's that flow broken down. The if condition fails. Python completely ignores that block of code, jumps right down to the else block, and runs that code instead. One of those two paths had to be taken. Okay, so we can handle one condition, and we can handle a condition with an alternative. But what happens when life is more complicated? When you have 3, 4, maybe even 10 different possibilities? Like, say, assigning a grade on an exam. This is what the if-else ladder was built for. Now, elif is just a mashup of else if, and it lets us chain together a whole series of conditions. The key thing you have to remember, though, is that it stops and runs the code for the very first condition it finds that's true. Let's check out this little grading program. The score is 85. Python starts right at the top of the ladder. First question, is the score 90 or higher? Nope, 85 isn't. So that's false. It just moves down to the next rung. So the next check is the elif. Is the score 80 or higher? Yes, 85 is. That condition is true. So Python executes the code for that block, printing grade B. And, this is the most important part, it then exits the entire structure. Its job is done. It doesn't even bother checking anything else. Now, to make all of this stuff work, we've got to follow Python's syntax, its rules of the road. Getting these right is absolutely crucial for avoiding errors, so let's do a quick run through. There are 3 big ones you have to nail. First, indentation. Those spaces aren't just for looks, it's how Python knows which code belongs to which condition. Second, the colon. Every single if, elif, and else line has to end with 1. It's basically telling Python, hey, a block of code is about to start. And third, and this is a biggie, use a double equal sign for comparison. And this slide right here shows probably the #1 mistake every beginner makes. A single equal sign is for assignment. It gives a variable a value. A double equal sign is for comparison. It asks a question. If you use the wrong one in an if statement, you're going to have a really bad time.
And believe it or not, what we've covered is really just the beginning. Once you're comfortable with this, you can unlock even more powerful tools. You can nest if statements inside each other, use logical operators like and or to make really complex checks, and even use Python's newer match case statement. But at the end of the day, it all comes back to this. Everything from a simple video game to complex data analysis is built on these exact ideas. These three keywords, if, elif, and else, are your core toolkit for building programs that can adapt, respond, and make smart choices. And really, that's the whole point. You now have the fundamental building blocks to give your code a brain. So the only question left is, what decisions will you teach your code to make next?